Hi, I'm Connor with the University of Toronto's Human Powered Design team, here to explain to you our innovation report and design for this year. A bit about our design: we wanted to add a feature to our bicycle to alert the rider as to when going around a turn, how close exactly they were to rolling over the tricycle. My partners and I came up with an idea to use an accelerometer and read the data, sends it through a Bluetooth module, and then we've created a simple interface where the rider can visually see this data as they're on the race course. Here's our user interface. Here is the final prototype, and as you can see, when I'm tilting the prototype one way to simulate the bike accelerating around one turn, the user is displayed a gradient to let them know how close exactly the bike is to rolling over. Right now, the green, it tells them that it's not too close, whereas if the acceleration reaches this level, that means that the bike is basically about to flip. Same thing on the other side when I rotate it this way to simulate the bike turning in the opposite direction. Basically how it works is that we worked out how to take data from a triple axis accelerometer and relate it to the geometry of the bicycle through vector spaces and some fairly non-intuitive algebra to determine with the microcontroller in conjunction with the accelerometer and calculate exactly what are the appropriate conditions for the bicycle rolling over. Our prototype met expectations because it's able to display this information with a high degree of accuracy and fidelity to the rider, and also exceeded expectations because we really wanted it to be displayed in a way that was as visible and as possible through the most user-friendly interface we could make, so that the rider can then take it and make snap decisions to help our chances in the race or to better their safety. So our final design was executed very well, and this is due to the fact of our constant refining different prototypes and ideas throughout the semester to make sure that the final product was as functioning as possible and outputs the best data that's going to obviously help our rider and keep them safe. So for example, some of the things we learned from or had to improve on was the latency time of the accelerometer and the transfer of the data from the accelerometer and the Arduino onto the user interface, which was about 1 to 2 seconds. So we had multiple iterations of our program to make sure that as soon as the bike experiences a change in acceleration, that this is displayed immediately or almost immediately to the user. As you can see, that